the expensive way to do it, which is the PC3000, and there's the cheap way to do it, which is MHDD, the tool that Dimitri wrote. Someone wrote a script to copy the data out of the ROM and put it back on another drive. It's on here. So when you copy this stick, you will have the script for that process if you end up being without PC3000 and you need to make it happen. I'm not going to tell you it's the easiest thing in the world. The easiest thing in the world is hit the button on the PC3000. The second thing that's the easiest, solder that. I mean, if you can get this to work, then that'd be great, and that's not a problem. I know people who have and been fine. Otherwise, I solder that chip. It's not too bad on infrared. It's pretty bad on anything else. Hot air, an iron, those are hard, okay? But most of the chips are patched. Most of them are patched today. So as they age, they tend to patch them. Western Digitals have a unique problem where the board is a lot of the times the problem, and the drive will click like it has a head problem. It will click and it'll go click, 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 and you can't tell. It doesn't sound like it's scraping, doesn't sound like anything's wrong. My standard mode of operations is get a good known working board, swap the ROM, put the board on the Western Digital, see if it works. And I will say maybe around 60% of the time I find the board is the problem and not the head in the drive on a Western Digital. I would say 80% of the time on Seagate it's the head. 80% of the time the heads have failed, caused the problem on Seagate. On Western Digital, 60% of the time it's the board. Everybody good? Now, not the Western Digitals don't fail, their heads do fail, but I cannot tell till I've swapped the board because it will give you the wrong impression. There is a problem with some of the Western Digital boards where a portion of the board fails and it still creates a scenario where the drive sounds like it's running, but it can't do anything. It can't communicate. So my standard motif is I have a working set of Western Digital drives, I resolder the ROM, I move the board over, I make sure it's working. I need a working Western Digital drive to start with. I always make sure I have a working Western Digital drive that I can swap that part with. Good? All right? So I always start with the board. Always. And then move from there to the head. Okay? All right. So firmware, I already told you no. I've already gone through like some of the sounds and those kind of things. If the motor doesn't spin, if I get completely dead, here's what the TVS looks like. Transients voltage suppressors. On this drive, I'll pass around so you can see it. Where to it? Seagate. So right here at the back on the bottom, there is a block, 2 blocks. There is a 5 volt is the small one, 12 volt is the big one. Those do not need to be on the drive for the drive to work. Okay? You just can't let any bad pulse or anything come through. So when they die or they fry, a lot of times it's because there's a bad power supply. So somebody used a cheap power supply. So when you get it, you can rip them off. You literally can snap them in half with a pair of cutters and make sure that the two sides don't touch each other. That's it. That's all you're doing. Okay? Now, are there other ways to tell? So those two, the small one is 5, the big one is 12. So when you see them like this, that's your 5, that's your 12. So when they're connected here, and sometimes they'll be on the board over here, sometimes they'll be down here by the motor, but generally they're right by power. Yep.
So you got 5 and 12. Can you power on either? Will it power up with either one, or?
Nope, you need them both.
You need both, yeah.
Yep. So if one goes, then it won't run. It won't run correctly.
That's what I was wondering.
Yeah, it shorts the power. So, and so you'll see them like this, and when they go, now you can test them individually with the continuity tester. Okay. I'll show you if I can.
So, but I mean, so you need a 12 volt line and a 5 volt line to power hard drive?
Yes. 3.5. You do. Yes. Yeah, on a 3.5 you do, not on a 2.5. On a laptop drive, it only needs 5 volts. Okay.
So what, 12 volts is the motor and 5 volts is the head?
You know, they get to decide on their own how to distribute the power. So it's not always consistent, honestly. once they have the power through there. But generally speaking, the motor needs 12. So yes, usually that's the way it works.
When those fail, they're failing in a shorted position?
Correct.
And so you're just opening the circuit by
Correct. Okay.
pliers and creating a physical open hole.
Yep. So I have a continuity tester so that when you touch the two together, it will go off, right? So on the drive, is it still going around or everybody already got it? So, so you can.
So it should be open.
Yes, it should be open. Right. So if I have one, then just so everybody can see here. So if I have one, and I have two sides right here. So if I touch one side and the other side, and it's open, then it's fine. There's nothing wrong with this one. Okay. And same thing here. So if that's the case, then it's fried. So if I get continuity, it's a bad one. So you can choose just to snap off the one you want. Generally, and you probably do the same thing I already do, I don't even look anymore. I don't even bother. I don't need them to run. So if the power doesn't work right away, snap, snap, plug it back in. Does it work? Oh, happy day, I'm on my way. And that's it. And I clone the drive, and I always still clone it. I always clone the data. I still give them back and ask them how they want their recovery done. So now, by the same token, you can switch to voltage, and you can watch your 12 and your 5 volt channels. When they're powered on, you should see like 4.93 and 11.67 or something like that going across the channel. So you should be able to monitor that. If you have any of the other tools up on the higher end, for example, see there's a power monitor on. Now, this is a module you pay for on a DeepSpar. Most of them have them except for this one right here. This one doesn't have the monitor on it. But see the M? Monitor? So I'm monitoring the current power, and so you can see the 5 volt channel. So that's a 2.5 inch hard drive. It's not a 3.5 inch. If I turn it off, you'll see the power drop, and then power come back on. So I'm actually power off, power on. Now that part is noise. The bottom part is just noise on the line. So I can switch to voltage, monitor to voltage, and that's what these tools, and all three of them actually have a way to do that. There is a way to monitor. I don't know, did the PC3000 add that later? Is there a power monitor on your PC3000?
I'm not sure, but we don't have it on ours.
The ATOLL, and that's primarily where I use the ATOLL, is to monitor power if I want to see it, because it'll actually use it against its own database. So in the ATOLL, there's actually a process for that. I'll show you, even though we're a little behind on it.
2.5 volts roughly, is that what it's showing?
Yes.
Then that's scale.
No, what? Say that again?
There's no scale.
Oh, no. No, you don't have to worry about that. It's just going across the 5 volt channel. That's just how much power consumption you have. Now, I will tell you one of the other things you can tell from this chart. If you consume a lot of power, more than average, so in other words, on a 12 volt channel, it should also be about 40-50% when I have a full hard drive on there. If all of a sudden the power utilization is up here at like 90-95%, that's probably a bug. That's probably something's caused the channel to tie up and a firmware has actually crashed and it's consuming all the power. So a lot of times you can tell basic stuff by that premise. You kind of get used to seeing it over time. I couldn't give you a chart for every single possible choice, but let me give you kind of a quick rundown. So this will be the first time I've showed you an ATOLL in this class, and I'll be too far off of video for people to see me, so I'll have to keep walking back and forth or something. So on an ATOLL, the ATOLL is an all-in-one. It tries to do diagnostics, it does everything. It has multiple device management across the top too. So you can add in other devices, image files, hit the plus, add one, hit an external hard drive to add it to it. It's pretty infinite. There's a huge number of things you can do here. In-case files, all kinds of things. So when you start out with the drive in the source. I'm writing to a target. So I'm going to say on my source drive, and I've already run stuff so it has a report and stuff, but I'm going to start it again so you can see. But You power on, it reads if it can. You still have to read your system area, you still have to get your content. If it doesn't read, it has a diagnostics mode where it tries to tell you. So I'm going to start here. I'm going to say, all right, I've powered on. I'm going to re-identify. It's going to go through the process of identifying the drive. So I am able to read the basics of this drive. If there was some problem and I still couldn't read some of this, I can actually read some data from it. So there's an ID component, which is right here. So these are all the bits that it pulled during the identification process, and SMART and other tables and stuff that you can actually see. So it's actually trying to pull some of the data so you can see, even for its ID part of the content. So you can actually get a lot of detail out of the system you can't see with some other tools. Now, that's just mostly for informational purposes. You can save it, do whatever. I'm going to show you. So the plan here was you would go straight to diagnostics and you would do an automatic checkup. So you would start right away and say go. And now it's going to start by running through the list of all of these things to see what it can tell you. Now, there's a good thing and there's a bad thing. Now, in this process, on the PCB board, it's trying to populate items and registers on the board and then read them back and see if the content actually matches. So that's what it's doing, is it turns off the power, it goes through the process of reading that. I'll pull the report back up so you can see it in a minute. And then power across the oscilloscope for diagnostics, that is reading content and then comparing it to a database that it has to see if in these certain situations, if these three things happen for this model of drive, it could tell you you have a bug, you have a problem. It's a probable, it's not 100%, but it's a pretty good guess. You'll also see now as it's going through heads, so it'll start with the heads, it's going to read individual heads, it's going to test in 3 areas of the drive and the quantity of the heads for speed. And it's going to see if you have a dead head or a degraded head. So it matters to me if it was slower than the other heads. So he added a test in there which will actually tell you the speed of each individual head. And then, so it'll take a few minutes for it to go through and check each head and go through the process. And then it builds a table on the fly. So the stuff I had to do on the deep spar where I had to tell it ahead, you generally don't have to do here. It'll do it on the fly from the table. So it goes through a process of checking the heads. Then it's going to go to the media surface. It's going to read the beginning, the middle, and the end. And the reason is on Western Digital drives, there's a failure on the board that causes you to be able to read one half of the drive, but not the other half of the drive. So it checks both ends of the drive. It's mostly Western Digitals that have that failure. So now we're just watching it. Like, this is the quickest, most automated, single button approach. I could just give a stack of drives to a college kid and say, hit this button, and anytime things don't work and it says it didn't work.
Now, does it propose solutions, or?
It does.
Like, I assume in the degraded head, you'll try to capture the drive reading it,
well,
slower than normal speeds?
No. It proposes a solution with regards to how to image the device, but it doesn't do that for you. You get to choose to do it. So you get that option. So you'll get to select. So you do have to use a little bit of your own brain power to decide. It will generally try to image it and do it on its own. But if you know that one head is slower than the other and you want to get it done faster, you can see this chart and then you can decide yourself.
You can shut down that head, shut down the head, do the image, turn the other heads back off, turn the slow one on, and do it that way?
Correct. That's what I normally do. I normally do all the fast ones first. I don't even, because if it's a degraded head, it's dirty, something else happened, maybe there's a scratch, I don't want to really focus on that one right now. I want to get all the good ones and then worry about that one after the fact. So again, I'll still do everything. And you can see across the bottom also, see the status lights down here at the bottom? I've got a physical link, which is 3 on the deep spar. That's what the 3 in the top left-hand corner means. And then over here, drive seat complete, drive ready, and then busy. So right now, it's in a hardware state looking at that. You can see from the board, see it says circuit board passed. So right here, those are the registers. It filled some registers, it checked them, it looked for voltages, and check the voltages across the line. It knows it can read serial number. It knows it read the firmware. And then these charts up here, it compared to a test to see how that worked. And like I said, it has a database of the output for all of the content they add to on the fly. It actually reports in. Occasionally, it'll actually phone home and update other databases to tell you what your problems were. So it's taking a little bit of time here, but hopefully it'll get done soon. But, you know, checking the, I don't even know how many heads it is. I don't even know. I just throw drives on it. It's a Seagate. That probably shouldn't surprise anybody. Anyway. There may be certain things because Seagates require the terminal port to be connected, and I didn't connect the terminal port. So there may be something that it can't do because the terminal port wasn't connected up. But for demonstration purposes, I think it'll be fine where we're at. But so there it goes across, and it's looking at speed across. It knows it only has one head, and it had no performance decrements at all. It read the same speed all the way across. If it had multiple heads, they would be listed here, and the chart for each speed for each head would be there as well. Then it reads your smart area, reports its failures. So it knows right here there is no partition. So now it gives you a report that you can then save or print out or do anything with. And so the top part is just information. Then you'll see there's no major hardware issue, but it'll say, oh, you should image this drive because you have blah, blah, blah. It knows the HPA is active. So you need to reset the HPA if you want to do something. Then your partition, no partition's been found. Compared your diagnostics. So this is where your speed. This is your 12 volt. This is your 5 volt. And so it'll run through all of those choices. The board we just did. If you had individual heads, which we can hook up, and you guys can do it. I mean, the machines are back there. You can do any of them this week you want. It'll show a chart for each one of the heads, and then it'll go through the process, and you can actually see all the stuff that it did, then your performance stuff. This is the smart table, the defaults for the smart table. Then you can decide what to do. And then everything else is done per device. So if you look, I'm highlighting this device, but if I want to deal with the other target, I can actually switch to that one. So I can switch back and forth between what I want to work on. And then when I go to image it, so what you've been used to seeing on the deep spar where I hit to start imaging and all the green dots, this is what it looks like when you do that on the ATOLL. So I'm going to start. I'm going to image all the sectors on the drive. I can also choose to do just ones that have data, but there isn't any data. It's going to do 5 passes. I can control all of those passes. So top part is a part you can zoom in on, but it's basically going to do kind of like the green dots that you're used to seeing on the deep spar. So as it goes across, it's going to show you as it's imaging the data. So I'm actually, right now, I must have modified something. I'm in a backward state. So I'm imaging in reverse. Huh?
I was going to ask that why it started.
Yeah, I probably, so the one thing about the ATOLL is, so all the other equipment in here, I pretty much wipe when I get back to the office before the next class, so no one finds anybody else's data on anybody else's stuff, except for the ATOLLs. The ATOLLs are bound to the machines, so I'd have to reset everything back up every time. So they are actually numbered. I have 10 of them, and they're bound to the machines. So I don't wipe those. So whatever my settings were last time, that's the settings I'm using this time. So I should probably set them back to defaults. But, so I'm imaging backwards. You can set all of those things up in the passes in the imaging settings that you want. There's 5 current passes going on, so I can go forward, backwards. It's slower going backwards than it is going forwards. But you could see, I mean, you can still see what's going on. And there's also, it's an empty drive, but I'm responsible for this box down here on the bottom. Dimitri was coming to a conference and he was going to show it. And I said, I'll demo it, but I'm not going to demo it until you have a hex box that shows me the sectors as they're being read across it. So he added that so that I could get access to it. I don't know if I can get the screen to... So it's an empty drive, so you can't see the sectors as they're refreshing, but you can actually set your refresh rates because it'll affect the speed of the drive. But as it's reading, you can actually see content of the drive as it's going across. And you can stop it. You can stop it and go look at something. So we could go look at the first sector if we wanted to. So there's a number of different things that go here. And then you can actually write this. I happen to write to a hard drive. I'm writing it to another hard drive because I'm writing it to this target. But I could write it to anything. I could write it to an in-case file, I can write it to a DD file, I can write it to a sparse image file. I can write, because it's empty, so it would actually compress pretty well.
So I can image to EO1,
Uh-huh.
if I want to take that back and use our Linux tools that we've been using for everything else.
Uh-huh. Yeah, it's one of the options in there. I don't do that often here, but you can actually, huh?
So you can make the source an image file and bring it to a hard drive using that.
Yes. Yep. But you can image straight to, you go pick your storage, you pick a place for it to go, you image to an EO1 file. It'll actually image directly to an EO1 file.
So, in your video, the videos I watched last night, you were showing the deep spar would do like, you could turn off ECC and then do passes and it would kind of average out the blips.
Yes.
ATOLL, will it do that or only the deep spar?
It does not build an array like the deep spar does. So the answer is currently no, but I have had that discussion with Dimitri, and that is supposedly something he is adding. So supposedly they are working on that additional item so they can build an array for ECC. Nobody has it, not even PC3000 has it. Deep spar is the only one who really has it.
What's the size on your source drive there?
The source drive is I can't quite see it here, but it's on the diagnostic screen. And then it's this is a 160 gig drive. It's right here, it's 160.
Okay.
And then I could have seen it on one of the other screens when I was messing with it. Here's the imaging settings stuff. So here's all the stuff you can do with error handling, miscellaneous, what you're doing with your heads. So you can switch heads. There's only one. So there's only one to use. And then here you can decide what you're going to do with all your passes, forward, backward, blah, blah, blah. You can do ignore ECC, but it doesn't do an array. It only does one. So it doesn't solve the problem from that standpoint. What's that?
I so badly want one of these.
Yeah, it's got a lot of great features, especially for what you're doing. For your stuff, you can switch in between different stuff. You can add as many passes as you want. And every one of these, so unlike the deep spar is always one session. It's one session, and every change you make is only for that session. On this, let's say I did part of what I wanted, and I wasn't necessarily happy. I can stop what I'm doing. So I can go back to imaging.
Can you unhook the drive, do something else
Yeah.
with it, and then resume?
Yes.
Wow.
Yes.
That's
But you can do that on DeepStar too. You can do that on all of the devices. But so I've got a session. So I've done 2 sessions. I did one when I set up on Sunday. I did one today, and then here create a new session. I can start all over, and I can redo it with all new settings. I can decide a whole new set of settings. I can decide new passes, whatever I want, modify them, do pre-hash, do whatever I wanted to, change the order of anything, and then I can save that and then come down here and start imaging. Now, you don't see it right away, but so I have one whole segment that's going on that's different than any other segment. So what will happen is if I stop it, say yes, now when I go back to imaging, it didn't start copying anything yet, but there would be a third session once it started copying data. So you can have one session after the other. So you can keep making, like I can go back and resume from this session, and it will not recopy data it already copied. So like I did the first session, and I've copied this much. In the second session, I didn't copy the same amount, I only had 0%.
We capture multiple drives of a person who's being investigated, but we didn't happen to have the laptop. We just started and we're halfway through an image of a large desktop drive, for example. They're like, hey, we just got the laptop drive in. That's a high priority because what we want most urgently is on that. I can pause this, unhook it, do the laptop drive, and then do whatever we need to do with that, and then pick up where I left off on the desktop drive.
Yes, sir.
That's pretty nice.
Yep. All of it. It'll do it all. At any point in time, stop it, turn the power off, start all over, reset everything, and you can do it session by session. So, like I said, I mean, you can make any changes that you want, and this machine is the most all-in-one solution at once. It does your It does your diagnostics, does your layout, you can do multiple I mean, it's so complicated at certain points that there's so many things that you can do. You just have an infinite amount of options. The problem, like I said, the only problems I have with it is the quantity of drives it supports. It's mostly newer stuff because this tool came out it's pretty solid about 2011, 2012. Pretty good. As of 13, they started adding a lot of features. So
We deprecate stuff pretty quick, so
yeah.
a lot of times we only deal with fairly new.
Right. So, and if you did, I will tell you honestly, if you had a drive that you had a lot of in your organization that it didn't support, and you said, Dimitri, listen up, buddy, I got like 20 of these things that I need, he would get them to add that to the code. So he would add the support. He does it for me all the time. When I bring stuff up, he tries to increase the, why do you need this? I will then go and assess it, and then we'll do it for you. Sometimes pretty quickly. So I've been pretty impressed with some of those things. Not that every single thing has been added.
Right.
And then you have the option, like I can actually just, I can be like, oh, I don't like where it was. Let's go over here and take a look at this part of the drive. And then it'll jump over there and start imaging from there. And then you can multi-pass, you can do the whole thing. It eventually will get the whole thing. It is very automated from that perspective.
That black spot there, right there, that black spot, that's what.
Yeah, that's where I skipped. I clicked it and I skipped, so it restarted at a new location going there. And so, because every time I do that, like if I want to come over here, and I now want to do here, now to make a gap for the session that I just told it to move. Eventually it will get them all. I mean, when it's done with this pass, it'll turn around and go the other way.
So it'll piecemeal, because you just did that, if you let it complete, it's going to end up piecemealing it, and the hash of that image would be the same as if you just
So they have,
straight up.
well, so when the entire drive is done and you hash it, yes, then it will always be fine. If you had bad sectors, hashes technically from the bad sectors would never hash the same. And so he came up with this theory called segmented hashing. So he can hash segments, and the segments are good. And you'll see that in, it's, trying to remember where he put, there it is, segmented hashing. So you have this option called segmented hashing, which is a fairly new concept from that standpoint, but you're hashing the individual chunks from here to here, and it will hash them in groups, in chunks. So if the whole drive doesn't get invalidated, is the point. Does that make sense?
So we have drives that wouldn't necessarily even be able to be read by normal, normal means, not having access to one of these. This would, I'm assuming, would be able to identify which sectors were bad. We could image everything else, hash that, and then have segmented hashes for the other stuff that we're trying to do by the multiple passes,
yes.
backward passes.
Yeah, I mean, you pretty much have the option to do whatever you want. So you can do the entity as a whole, you can do the segments in between. I mean, that's one of the reasons why, he's gone down this path and he's been attacking forensics from that standpoint, is to answer all the questions that you're asking. He's got most of them done. I wish, the only thing I can really say I really want bad is the array for ECC, for ignore ECC, which is what the DeepSpar does, which some of the newer drives don't support it anyway, so that's the other problem. So newer drives don't necessarily support ignore ECC. So, everybody understand? Everybody good?
That ignore ECC is what makes the deep spot best for.
In my opinion, that is true. But brand new drives sometimes don't support that setting. And certain drives don't, like Samsung and Toshiba. Like those don't support that setting. So regardless of that, I mean, the day will come where ignore ECC might not be super helpful. Does that make sense? But as of today, I still consider it to be a really important factor. Okay? All right, so that was the basics of what I was trying to get across to everybody in the diagnostics phase. And so, like I said, you can always test a board by covering up these pins with a Post-it note, putting another motor, put another board on, get the motor running. I've had to hot wire them before to test them when I couldn't get a board working. So that's pretty much the breakdown of what those items are that you can use for diagnostics. So firmware, now keep in mind, so head damage and platter damage, they go hand in hand. You can usually almost always see those. It's almost always going to leave some platter dust somewhere if you have physical damage like that. You can have heads that are damaged without scratching the platter, but most of the time you cannot get the system area to initialize. So you don't even get to a spot where you really, in most cases, have a firmware problem. And then motors are pretty easy, pretty straightforward from that standpoint. The only one you're pretty blind on is firmware, and without a firmware tool, there's no easy way to deal with that. So system area. You can tell where your system area is supposed to be, and the head, when we start looking at it today, we're going to be doing the drives live in just a minute, hopefully. When the head moves to the location, you can actually see it intentionally go to a location, read the system area, and then return to another area. So it's actually trying to do something specific. And so I have, let me see if I can pull this video up to show you.
Discontinued. 6 to 9 years from now, I'll be back.
All right, let's see. Here's one. So watch what the head does. So do you see the difference in the first part and the second part? I'm gonna just run that again so you can see, and then I'll come back and we'll do the second one here. So you power it on, the head goes out here, it's seeking system area, then it just starts clicking. You see the difference? And then the same thing here, it's going to read the system area, which happens to be sitting there, and then it returns. So, or it may go to another spot on the drive or something like that, but it's pretty intentional. You can see it happen. And when you're doing the drives, you're going to see that. And you'll see that exact same thing when you're dealing with even damage in a lot of cases. Wherever the head goes the most often is usually the part that's scraped the worst. So if that's a part where it gets hit or it's bent or something like that, that was where the system area was on this platter, and it has been scraped off. So what is the only chance that I'm going to get this drive back?
Initialize it and do this swap of the...
A hot swap is probably the only thing that's really going to work. There are some tricks with the PC3000 where you can load ROMs and you can load content from a system area from another drive into memory and pretend that this board already worked by stealing the content from another drive and get it working. It's essentially a hot swap, but a more intelligent version of a hot swap from that standpoint. But those, in that situation, there are tables that are unique to that drive that only in rare instances are you going to get it to start up again. So it's very difficult to get past a spot where something has scratched, especially the system area. Okay? So, that's...
You said the system area was in 2 locations.
Sometimes, but guess what? Can you see that this was glass? And you can see right through the platter. Can you see? I mean, I can see it at this point. Most of the time, the system area is exactly on the opposite side. So where it actually is, now there's sometimes they're side by side. But wherever the head goes to the most often, now if a system area, if there was 2 system areas, the drive initializes on one and it fails. Let's assume there's a soft fail. Something happens. It didn't scratch it necessarily. Okay? It will automatically switch to the second table. You don't even have to know anything. The drive does it on its own. It has copy 0, and if copy 0 cannot be read, it automatically tries copy 1, which means the drive would have initialized on copy 1. Copy 0 is already dead, and it's never going to read again probably. It's going to try it every time you start up the drive. You're going to get a delay. Then it's going to read copy 1, and then it's going to continue on. You will never know you already are 1 foot in the grave.
Well, like smart or anything doesn't...
Nope, because guess where smart is written?
System error. System error.
Generally, it will not tell you. Generally, it does not warn you in any way, shape, or form. There is nothing else except for a PC3000 that says you are running on copy 1 instead of copy 0.
Do you usually turn off smart and all that?
I don't. There was a time period where I did manually for certain reasons, but I mean, are you saying in a data recovery situation or in a day-to-day?
In your day-to-day usage, like
Nah, I usually leave it on.
New laptop, are there certain drive settings that most of the time are on by default, or most people use by default that you?
For a while, they were off on a lot of drives because manufacturers, when you bought them off the shelf, did not want you to have to return them for some reason. But generally speaking, they're on most of the systems today. Most of the systems today are already monitoring smart, but smart doesn't. It's supposed to be a preemptive failure, but it's not. It really, and it has been dumbed down a lot because manufacturers don't want to replace something under warranty.
Is that why they don't tell you track 0 is dead?
Like
You're on track 1, because you'd be like, whoa, I've only got one.
Well, yeah, and there still is a track 0 error. There still is a track 0.
Most people don't know what a system error is, like the general public. Oh, system error, but it works, I don't care.
Right. They don't know. But if it said copy 1 failed, what would they do? Right. Who are they gonna call? No.
Manufacturer.
Yeah. Usually it's the hard drive manufacturer, right?
OEM, they're probably OEM, so yeah.
So let me point this out to you. Maybe you guys don't know this part of the story. So remember when you used to buy hard drives and you had this jumper on it and it said master and slave? You remember that? And you had a problem and you couldn't get 2 drives to work together no matter what you did when you put that jumper on. You guys remember that? And we actually had a phone number and a support line to call our hard drive manufacturer. There was a day and time the hard drive manufacturer had a support line. When was the last time you called one? Been a long time, hasn't it? Right? So this is how the meeting went. There's no joke. I'm not kidding. You can probably find it. You can probably find the transcript somewhere online. So the group meets and they say, you know what? Our most expensive expense is phone support. So we're telling people where the jumper is. So we added this jumper, master, slave, cable select. And sometimes it doesn't work, but we think it's because the user is an idiot, right? So they call us and ask us where to put this jumper, and half the time they can't figure anything out. So we're going to come out with this new spec, and it's called SATA, right? And remember in IDE cables, remember in an IDE cable, you had, you had a position, right? You had your first and your second position, and if it wasn't done by cable select, then you had to have your jumper, master, and slave in the right place, right? So that it would terminate correctly at the end of the cable, right? So this is an expensive phone call for the hard drive manufacturer to deal with. So they have a meeting, and they say, we're going to come out with SATA. And how many drives go on a SATA cable?
1.
Do you know what the chipset supports? 2. No, it supports 2. It supports 2 on the same cable. It does, but they got rid of the second one. You know why? You're too stupid to have a jumper. I'm not kidding. That was really what they said. They really said, listen, the public is too stupid to have a jumper.
You want 2 drives? Buy a motherboard with 2 settings.
Right. So immediately, right, you immediately went from a connector. There was 4 connectors on the board on standard ID. By the time it was done, you could have 4 of these. So you could have 8 drives, right? 2 drives on each chain. And then the exact same motherboard comes out, and they replace that. And no, you can only have 4. The chipset supported it. You can still do it. The OEMs order them according to their position. This actually is already keyed as master. They're actually you can actually buy a slave. You can have 2 on the same chain. It does work. You can do it. I've seen it. I've taken apart some manufacturers when I was doing some work for Sony. They have them and they make them. You can do them. So you can even put a CD-ROM on the same chain. So you were too stupid to have a jumper. So they got rid of the jumper. Now there is still a jumper on some of these. You know what the jumper is for most of the time? Speed. Yep. Yeah. 1.5 gigabit, 3 gigabit, and so on and so on. And then when the jumper's there, it's set to the default of the slowest speed. So when you buy the drive, if the jumper is on it, it is set to the slowest speed because that is the most compatible across all of the connectors. Now when you pull that jumper off, there also are two connectors on there that are terminal connectors that we in data recovery use to talk to those terminals. But it is in default by the slowest position when you buy them as external. But they said you're too stupid to have a jumper. And so that's why. And so therefore, no longer do hard drive manufacturers really, I mean, they have a warranty support line. That's it.
Yeah, you call it, go to our website, www for more information, then type in, and then you do it.
Right. Yep. And then you do a serial number. So
Here's a checklist of how we can blame the problem on you.
right, that's exactly what happened. So nobody blames the hard drive manufacturer, and they're the ones who caused the problem. All right. So we already went through all this. We've done this. All right, so we're going on to, I want to start talking, these were all the screenshots of DeepSpar stuff. I'll go through some more DeepSpar stuff as we're going through it. I want to get you started on hard drives because it's already like 3 o'clock. All right, so we're going straight to here. Breaking down. Now, I'm really throwing you into the fire, but I'm going to explain as much as I can, as quickly as I can, on how to do this. Okay? Okay. So we're on page 352. 352 in book 1. We're going to break the hard drive down for disassembly. Now, I'm going to describe the steps to you really quick, and then I'm going to go through this process, and then I'm going to describe the steps to you again. Okay? The first one is, we are going to write 2 gigs of data to our hard drive. I'm going to give you a stack of hard drives, one at a time, and you're going to use your USB connector that's in your box, in your bag, in the black bag. You're going to hook up a drive to your laptop. Some of these drives are surplus drives, they're old, they're beat up. We did test them to make sure they work, but sometimes they cause a problem on the bus, on the connector, whatever. We'll get them formatted somehow, we'll get data on them, okay? Most of the time it'll work, you'll plug it in, it'll work, you can copy 2 gigs. I have a directory set up that you're going to copy to your hard drive so that you can get that done, okay? Second, you're going to then take that, you're going to push everything else away, you won't need the laptop anymore for this portion. Once you have data on your drive. You're going to then break it down according to what I'm about to tell you. When you get into the drive and you can see the drive, you will make your own tools from the stuff that's in the black bag. And I will show you how to do that. And along the way, different numbers are going to have different heads on the drive. So you're going to open up a drive. I don't know what you got. It may have 2 heads, it may have 3 heads, it may have 1 head. I don't know what it has. They're surplus drives. I buy them for every class, and every month we destroy 100 drives. That's what happens. Never see them again. I don't reuse them. They go into the recycle bin. So, what?
You don't keep the boards?
Nah. You know how many I have these? I've done 100 classes. Do you know how many drives I have in my location? Just piles and piles of drives everywhere.
Where do you buy surplus drives?
These, I just search on eBay for whoever's selling surplus drives and has a good price, has a good selection of them, and then buy them. It's getting harder and harder to get Hitachis. It's harder and harder to get Samsungs. Still getting some Mac stores, still getting mostly Western Digitals and mostly Seagates, which are the majority of the drives that are out there. The majority of them are those. But when you see a Samsung or you see a Hitachi, those are pretty fun, take apart, put together. Those are not your worst failure. I mean, the Samsungs are pretty big failures, but there's less of them. They've been decommissioned for quite a few years, but you'll still see them in data recovery out there in the field. But they're easy to do. They're actually not bad to disassemble and reassemble. They're just a terrible drive. All right, so we're going to go through this breakdown and reassembly component, and I'm going to throw you under the bus from that standpoint. Then what's going to happen is you're not going to use the laptop to try to read the data back off of the drive. You're going to use the DeepSpar. So at that point in time, when you're done rebuilding and you think you've got a working drive ready to go for testing, we're now going to hook it up to the DeepSpar, and either you know what to do or I'm going to help you. Doesn't matter. And we will try to read the data off of your drive. And if you get green, if you have a head that reads green at all. I'm going to call it a success at this point. We can make the success better and better as we go, but currently if you are able to see anything and read from a head after removing the platters and reassembling the platters and the head assembly, you're doing really good at that point, okay? Or you're a lucky first timer, whatever it is. So I really don't expect anybody to win today. I don't expect you to get green, okay? So some of you that might have done it before are pretty good with screwdrivers and things like that, maybe. But generally speaking, I don't expect you. I expect you to go through the drive, get used to the parts, what the layout is, what it looks like, how it feels, put it back together, get muscle memory going, okay? All right, so here's what we're going to do. Hard drive, when you look at the inside, we're going to start breaking it down based upon the pieces and the components that go together. So I look at it as this. This head assembly and the electronics go together as one piece. Platters are going to go together. This electronics ends up going with this piece right here for the head because it's connected on a ribbon cable. It is called an integrated circuit board, even though there's no integrated circuit. And it's because it once had an integrated circuit on it. But now the circuits are so small, it no longer exists there. The circuit now has moved to here. So that's what's happened. And then we're going to break it down to its bare minimum. When you're looking at the actuator arm, there's a lot of things to look out for. Coming down the actuator arm, so when you're looking at the side of a drive, the head of a drive on the actuator arm, if there are wires, that's what you're looking for. Where are the wires? You may have heads below or above that don't have anything connected to them. They'll still have the piece of metal sticking out, but there's no head connected to it. So if you're making a tool, but you can't see if there's a head down there, you're looking at the edge to see if there's a wire. If there is a wire, there is a head. Sometimes it's hard to see because they're back to back. But when one's all by itself, it's pretty clear, okay? Also, you don't want to pick up stuff like inside your set of tools, there is a set of needle nose pliers and tweezers. You don't want to grab here and here because that's where the wire is. If you snap this little wire, this set of heads is bad. You can't use it anymore. If that happens, pretend it didn't and keep on going. Because your whole point is to build muscle memory. So if you make a mistake, live with your mistake. Move on. But you know at the end, if you did that, you plug it into the deep spar, it's not going to do anything, okay? You're not going to do anything except hit power on, and that's all you're going to get, okay? So then we'll move on and do the next drive. Just accept your failure. All right? It's all right. You're all men. You can live with it. One of you will fail. The others will all win. I don't know. Something will happen.
You can all point and laugh at me.
Right? All right. So next. So be really, really careful at the end. This part was called the gimbal. We call it also suspension. And this right here, if you bend it, if you ever bend the head in that spot at all, and it is not as flexible as it was, you will never ever bend it back to be able to read. Understand your head is floating over the platter in a very, very fine, it's nanometers over the platter. And if you bend it, remember, what we're doing was never possible. It was never meant to be possible. I mean, we're taking heads out. We're doing this. We're separating them. We're holding them apart. We're trying to keep them from slapping each other like this or sticking together. If that happens, pretend it didn't and keep on going. Just reinsert the tool, pretend it didn't happen. A lot of times it'll still work. If you actually get to the spot where you're like, dang it, I messed it up, most of the time that's actually when you know enough to know that you messed it up, that's when it actually will work. Because you knew enough that you made it this far to know how sensitive it was. And it will still work. So be really, really careful. Now this is a little more complex drive from this standpoint. It's still not scary. To me, it's not scary. You just have to practice a lot to get here. What's going to happen is there is a ramp out here on the side. And your heads are held in this ramp. Now I'm going to tell you, you can do anything you want when you leave this class. But when you're in my class, follow my procedure because I have a reason that I'm teaching it this way. And it's about standards and it's about process. If you think you can make something work faster, great, fantastic. Do it later on because it's not going to work. What's going to happen here is a lot of people see this piece right here and they think, why don't I just unscrew this and I take this whole assembly out together? Right, it'll bend it. You will bend those little pins right there at the ends of it. I promise, because these pieces have an angle at which they come in, and every time you try to do it, when you have no experience especially, this piece, now there is a way Let me tell you the way, because someone has made a tool that did this. There's a bridge board that somebody made that you can screw it right here, and you can come down here, you can screw it in right here, and you can lift the entire assembly up. It's really not worth the effort, honestly. I mean, I know it seems really cool and it's a great idea, but it's really not worth the effort, because all you do is, so what I would do is I would start spinning the platter. Now, which way the head's pointing? This way. So I spin the platter this way. I'm going to spin the platter. I'm going to move the heads onto the platter, and I'm going to stop right at the edge. As soon as I clear the ramp, I'm going to stop. Okay?
That won't scratch it because you're not spinning at a normal speed.
So a platter has about 6 layers on top of it. So there's thin film media, there's a seed layer, there's a coating, and there's plastic to protect it, thin film media, and then there's lubrication. So as long as you're not sticking a piece of metal and scratching it across it, you're going to be fine. If you don't bend the ends of these tips, it'll sound bad for a second, but it'll be fine. I promise. I've done thousands of drives. You can turn it and make a little bit of a noise, and it'll stop right there, as long as you're not eating into the platter. Okay? Scott makes all these noises. And I do it all the time. I'll be out with my girlfriend. I'll be like, ew. She'll be like, oh, ADD. So you'll put it right here at the edge. You'll stop. Now, if the heads were parked in the middle, I do exactly the same thing. I always pretend I don't have a ramp. If I have a ramp and it's here, I put the heads here. If it's here, then I'm going to spin the platters. I'm going to move it out apart, and I'm going to bring it right to there. And I'm going to stop. So I get them both to the same position. Okay? Then I'll be making, for this one, you can see I have bottom, other side, bottom, other side, bottom, other side. I got 6 heads. I'm going to make 3 tools. So I'm going to take 3 pieces of Sudafed container. I'm going to cut out my own little tools. They're going to have, this one's actually a real Sudafed container. And it's not the metal that I worry about, it's the plastic. The plastic's what you want, because that's what gives it the retention, okay? So I'm going to take that, and I'm going to put a piece of double-faced foam tape in between it, and I'm going to carve this baby out so it looks really pretty. And then I'm going to start at the bottom while the heads are on the platter. I'm going to come back here. I'm going to use my tweezers. I'm going to squeeze the piece. I'm going to insert it very carefully, because you see this? This was a Hitachi drive. See these wires that come down here? If you snap one of those wires, that head's done. The whole stack is done. Okay? Because you're probably going to just go ahead and replace the whole thing.
Now, how delicate are the wires?
They're pretty delicate. Very delicate. It's a very thin. It's a hairline wire. So be very careful. So I will insert my duck bill, long piece on the bottom, so it'll look like this. It'll look like long piece on the bottom. Insert it below, so it goes underneath the platter. So the head's on the outside. So if the heads are like this, okay, and the platter's in the middle, I'm trying to get in between the platter and the head. That's what's happening. So the platter's here, and these heads are like this. I'm going to insert my tool here, and my tool is going to come to here and separate the heads, but the platter is going to be in between my tool. Okay? So it's a duck bill sitting around it. It's basically the same shape as the way that the heads are. Okay? So, head combs, basically. So we're going to go through here. We're going to put it in the middle. We're going to then drag it down here, and it's going to be holding the 2 heads apart from each other, but sitting on top of the platter. Yes, my plastic is going to be touching the platter. Plastic to plastic, because it's lubricated and it's plastic. It will not scratch it. It will not cause a problem unless you stab it. Okay? Everybody good? I start at the bottom, then I build another one, then I go across the middle one. Once you've built a whole pile of these, you'll just have a box of them sitting in a corner and just pull them out. You don't need to make them every time. But, I mean, they only cost 50 cents to make, so it's not a big deal. And then I'll go to the top one. I always start at the bottom and work up, because you can't see the bottom once you've worked on the top. Okay? Good? Then, once that happens, you'll actually see that the heads become free and clear from the platter. They will all just slide out. Now, there's some things that have to happen before you can get the head assemblies out. Down here on this end, there's locking pins and things like that there's voice coil magnets that are going to hold things in certain places. I think of it in terms of what will do the least damage. I need to unlock this, but I need this piece off. And if these pieces come off while the head is sitting on top of the platter, then it might scratch them. So I think in those kind of terms, okay? So we'll step through that as we go. But yes, these little pins, if you leave them inside there, they will bend, they will do damage. You can, now I don't use paper anymore, but I used to use paper to do this job. And you can see like all the stuff it leaves behind that you have to blow off. But I actually did rebuild this SCSI drive with, there was 10 heads, 5 platters. So also be really careful about things like the ribbon cables where the joint is. There's a preamp on the joint. So at that spot there's an amplifier. If the amplifier gets, you know when you walk across the table and you touch your drive and static electricity hits it and then your drive no longer works? That's what blows. It kills the preamp. Most of the time that's what dies. So then your head assembly no longer can communicate with anything. It's actually abandoned. Okay? And anytime that you're dealing with, I had somebody say one time, so we went all week, and it was like Thursday afternoon. She'd been rebuilding drives the whole week, and if one of these heads goes bad, can I replace this one head? No. Why? I mean, I can't resolder that one head and that one thing. I replaced the entire stack, right? Like she said, we got to like Thursday afternoon. She goes, well, when are you going to teach us how to clip off a head and solder a head on? A different class. I don't know what class that is. You don't need to do that. You're completely taking the entire stack out and replacing the stack. There's no reason to do a single head, ever. And I can't even imagine what that would look like trying to solder that. I'm not that good. Be careful anytime you see things like this. This was done after the fact. The manufacturer knew there was a stress point inside the drive, so they made this loop that goes over the cable to keep it there so that the cable wouldn't separate. If you see stuff like that and you pull on it, it will probably come apart. Okay? So be very, very careful. Don't stab cables. The other thing that happens that people do all the time, so let's pretend this drive is closed and the seal is really tight, and I've removed all the screws and I know all the screws are gone, and let's pretend this is a screwdriver. What people do all the time is they'll come up here and they'll just start like prying on it, and as soon as it gets open, oh, stabbed everything. Stabbed the disc, stabbed the ribbon cable, stabs everything. Don't do that. Don't do that. Please just do it like this. Do like this. Come to the edge, and then that way when you pop something or you push your screwdriver through, it's going out and not in. Okay? Go that way. Some drives have a divot right here in the side, and you can put your screwdriver in and just turn, and the divot pushes up. Okay? I don't know what the divot was originally for. I think that's what it was for, but I can't imagine a hard drive manufacturer helping us in any way. All right. Now, over at the end of the actuator arm, there's all these things. You guys have seen that Toshiba commercial that like the laptop falls, and if the laptop crashed, the zombie apocalypse happens, and the guy's like, no, I'll wait for Toshiba to make, to send me the drive, whatever. There's actually a commercial like that. I'll have to find it. So this concept that as your hard drive falls, when it hits the ground, it will be turned off and it will be saved, because there is this part that actually turns off the laptop drive when it knows that it's falling. Right? It's true. I mean, there's an actual accelerometer inside the drives. They know that they're falling. They turn off power. The heads go back to a parked position. And when they go to a parked position, there's a locking pin. So like right here at the end of this one's using the magnet. So there's a locking pin by sticking on the magnet. Now on laptop hard drives, most of them are actually locked in place. So there will be a pivot point or some sort of a piece of plastic that is done mostly by air pressure. So what happens is the platter spins up and airflow happens at the air bearing surface. And there's a little locking pin, a piece of plastic, it pushes out of the way. So when it pushes out of the way, it unlocks it so the head can move. That's all it is. So a lot of times when you open the lid and you're working on a drive, you've got to be ambidextrous. You've got to hold the locking pin out of the way while you're making some adjustments with your hands. So This is where people get fingerprints on platters and stuff, but once you started wearing gloves, you get used to it enough, I'm able to do everything without ever touching the platters or doing anything. And I mean, it looks like I'll have like 3 hands going on at the same time. Like there'll be things going every direction. But you can hold them. There's ways to hold them. Otherwise, you also have tape. You have electrical tape in your bag, and the electrical tape can stretch over things, and you can hold things in place, okay? But pay attention to this. Now, when you open your drive, when you first take the lid off, take a photo. Also, keep track of every screw that you take out because they are different sizes. They will not go back together with all the screws randomly in a different place. So usually, you know, you take a piece of paper, you write down there was 3 screws of this size, you put them on the piece of paper, you tape over them so they don't get lost or something.